Welcome to the NVIDIA Nsight Graphics 2022.4 Release Spotlight. In this release, we've added some great new features that provide more in-depth information on the state of the GPU when profiling. We've also made some great improvements to the UI in order to improve your overall experience. The API Inspector has been redesigned to dramatically improve usability. This includes more intuitive display of critical fields, searching within API Inspector pages, significantly improved constant buffer views, and data export for data persistence and offline comparison. One of the most used APIs for Nsight Graphics is OpenGL, and with many academics, students, and ProViz developers relying on it to render high-fidelity graphics on the latest NVIDIA GPUs, we wanted to make sure that we could provide a cutting-edge profiling experience. I'm pleased to announce that GPU Trace now fully supports profiling and analysis for OpenGL applications on both Windows and Linux. GPU Trace is a powerful profiler that provides deep information on the GPU in order to allow you to identify the reasons for performance issues and quickly and easily resolve those in your code. We'd love to hear how GPU Trace has helped you improve performance in your application. With D3D12 moving towards updates via the D3D12 Agility SDK, we've made it a priority to ensure that we are supporting those latest features as quickly as they are released. D3D12 Enhanced Barriers is one of those features, and is now fully supported in this version of Nsight Graphics. Enhanced Barriers offers less latency, support for concurrent read and write, including same resource copy, diverse aliasing topologies, and better concurrency. Whether you use traditional barriers or enhanced barriers, both will be equally supported. Subchannel switches can now be overlaid on the GPU Trace timeline via a new checkbox. This helps you to better identify the potential performance impact due to a change in the graphics pipeline workload type. This is important for performance since this can cause a delay that will decrease SM occupancy and hardware unit throughput. By identifying where subchannel switches are occurring, you can reorder your graphics code to attempt to hide this latency and thus improve your application's performance. Per shader register count and theoretical warp occupancy are now visible in the shader profiler. Let's say we identify low throughput, low warp occupancy situation in GPU Trace. We can use the registers, shared memory, and thread group rows to determine the top limiters, which can point us in the right direction in the shader profiler. There, we can view all the shaders in the frame with the warp column showing maximum theoretical occupancy. In the column chooser, we can enable viewing of registers per thread, shared memory, and thread group dimensions. This combined information is critical in allowing you to optimize for warp occupancy and fully taking advantage of GPU resources. Finally, we are now deprecating the range profiler in order to fully commit our resources to improving GPU Trace. If there are any specific features in the range profiler that are critical for your profiling needs, please let us know so we can ensure that your use case is supported. Thank you for watching, and don't forget to send us your bugs, feature requests, and general feedback using the integrated feedback button at the top right of the window. If you liked this video and would like to see more like this in the future, be sure to leave a comment and subscribe to the NVIDIA Developer channel.